Hi, we're live. I send that text message. All right, so let's go through this quiz, this first quiz. Some of you might have noticed that on my YouTube channel there are the videos that I recorded yesterday. Reply to this real quick. All right. So, one second. Let me. I'm sorry. All right. Uh, so we're gonna do this video. So Code and Praxis 2 Level 1 Lesson 1. Uh, like I said a second ago, there are videos on my YouTube channel from yesterday's class. I will be posting today's video. Alright. A circular mill is a circle with a circumference of 1 mil. That is false. It is a diameter of 1 mil. Next up, a 6 gauge copper conductor is smaller than a 10 gauge copper conductor. You can look in your code book at any of the spots where it discusses conductor size. One of those spots is Chapter 9, Table 8. Or you can just use experience from the field to know that 10 gauge is uh, what we use for wiring in a house for some cases, and number 6 is like ovens and like heavy loads. What is the maximum size conductor that is generally permitted to be a solid conductor where installed in a raceway? So this section, if you look up conductors, I want to say stranded. Yeah, conductors stranded in the code in the NEC index, you will find that 310.106C is where it says, and it actually indicates 8 and larger must be stranded, which means that 10 and smaller can be solid. A lot of people get a little bit confused there. Uh, Change the following 0.125 inches to mils. It is 125. All you have to do is move the decimal 3 times, and that's it. Oh, excuse me. Change the following measurement to mils. 5/8 inch equals. So first, you're going to need to open up your calculator. So 5/8, to convert that into a decimal form, you'll do 5 divided by 8. You can see that formula right there. And it gives you 0.625. And you just move the decimal 1, 2, 3 to convert to mils. And that gives you 625 mils. 6 inches. Well, you just take the 6 and move the decimal 3 times to give you 6,000 mils. Good job, everybody, on that one. Alright, in this one, we're going to be finding the cross-sectional area of a bus bar. Let me pull up. So, if you look, this bus bar is a rectangle, and it was 2 by 1/4. So 2 inches by 1/4 inch. 1/4 is, so we have to convert the 1/4 to a decimal number. So that's 0.25. And we're going to move the decimal 1, 2, 3. So 250 mils. And then for the 2 inches, we're going to move the decimal to make it 2,000. So 2,000 times 250. That's going to be 500,000. All right. So, somebody got there. 2,000 times 250. I don't know why they didn't finish it, but they got close. Oh, excuse me. Need coffee. The circular mill area of a 1-gauge copper-clad aluminum wire is... So, all you have to do is flip to Chapter 9, Table 8 in your code book for this one. Chapter 9, Table 8. And that will give you the size. All you have to do is just look at the size. 83,690 is that circular mill size. There's no math to it. It's just look at a chart and you get it. I keep looking to the right of the camera. Just figure I'd move the camera a little bit. That's how you can angle the camera. Just move the whole damn monitor. What is the circular mill area of a wire having the following diameter? So 25 mils. The math here. The math that we'll use is, it was, need a pencil. Let's make that a little bit bigger. So that is, to get to circular mills, you're going to take your mils and square it. So let's do 25 squared. 625 circular mills. So 25 mils is equal to 625 circular mils. If you go on the Blended Learning website and look in the courseware, so go to your lesson on Blended Learning. I'll show that real quick. So on my courses, we're in Code Standards and Practices 2 Level 1. That's what is assigned this week. Lesson 1. Then you have, if you scroll down, you have this reference, Understanding the Principles Involved in the Sizing of Building Wire. And it's right here. This is where all that information is. All right. And, oh, that was the last question. All right. If anybody has any questions, be sure to connect to the Discord. I am sitting in Discord all day, ready to take questions. You are welcome to text me if you have any questions. If you're having any issues getting logged in, looks like Barbosa. Just need Josh to log in. If anybody can contact Josh. He has not responded to my messages today, so we will see. Yeah, in a couple minutes, I will be starting up the new quiz. Whenever I take this down, there was a handful of you that had bad emails in my room, and I'm going to update your email to the correct email. All right. So if nobody has any questions in here, I'm going to end the stream here.